Hi everyone. So today I'm going to talk about open infrastructure to create and share knowledge. I'll start off by introducing myself to those of you who have not met me before. My name is Jenny Wong and I'm a developer at 2i2c. My research background is in mathematics. I got my PhD from the University of Leeds. We've had a couple of mentions of Leeds, so shout out to Leeds. I worked as a research software engineer at the University of Birmingham. And nowadays, as of the beginning of this year at 2i2c, I help research communities get the most from interactive computing. So I do things like write technical documentation, design and deliver training events to help get them the most out of interactive computing in the cloud. So I'm going to focus on open infrastructure. And I'm going to frame this in the context of the last mile problem. So I'm going to talk about modular ecosystems and Jupyter in the last mile problem. So this morning, I got on a train from Leeds to get down to Leicester to have some delicious coffee with you all. And one option to get to Leicester this morning was I could have walked there by myself. Another option is that I could have paid someone to drive me all the way there. And then for my own personal reasons, my preference is to take public transport. So I had to hop on a train from Leeds, change at Nottingham, and then get on another train down to Leicester. And then I had to, get to the last mile and get to Leicester and this College Court Conference Centre by myself in order to get my delicious coffee. So that final part of the journey is the last mile. So what I want to emphasize with this framing is that public infrastructure gets us closer to our goal. It makes not only just my journey, but other people's journeys in which the last mile becomes a bit shorter. So it's important to have branching points, right? So I got on, a East Midlands rail train to Nottingham. And so that branching point was key in which to take me to my final destination. And so what I want to emphasize here is that public infrastructure should have many stops and branching points to get as many people as possible to their last mile. So how does Project Jupyter fit into this? So just to introduce the project itself, Jupyter is an open community dedicated to modular and platform-agnostic tools in interactive computing. It's an environment that is also sort of high-level language agnostic, so the letters of Jupyter itself are formed of the languages Julia, Python, and R. And the main way that folks can interact with it is through an interface called Jupyter Lab, which is an extension and built on top of the traditional Jupyter notebook. And these Jupyter notebooks are served using a tool called Jupyter Hub. So there's a bunch of different modular tools in order to provide that experience. So it's important that they're modular, composable, and customizable. And in doing so, the community is creating and supporting open standards and protocols to interoperate with others. Project Jupyter primarily focuses on interactive computing workflows. So we have a human in the loop, often the researcher, who wants to prioritize exploration, rapid feedback from their analyses, and communicating their ideas and disseminating their research to others. So if your end goal, your destination is, I want an interactive report for my analysis that I can share with others, how would you get there? So you have your starting point in which you could go ahead and build it from scratch yourself. And then the other option is that you could pay somebody else to customize a solution for you that is very bespoke for you. Or my preferred option is to build on open modular tools. So this is what a Jupyter notebook actually looks like. So you access it through a web browser. It incorporates text and math together. You also have separate code blocks in which you can execute code, which can produce some results and visualizations, and then you can share and reproduce that notebook. And to actually deliver that notebook experience, it's actually composed of a stack of modular tools. So you start off with having your package ecosystem, right? So you might be pulling in packages from the SciPy stack. And then for your notebook file itself, it follows a specific document specification. So for Jupyter notebooks, that's a .ipynb file. And then you have some kind of server protocol to serve that through the web client. To execute code, you will be using something like IPython for your interactive kernel. And then you'll have some kind of notebook interface for the user to interact with. So just to re-emphasize, the modularity of these packages and composability make the last mile shorter for different kinds of people. You might not want to be using a SciPy stack. You might be programming in Julia instead. You can swap that module, into this Jupyter Notebook ecosystem. You might want to be writing in Markdown files rather than a .ipynb file, so you can use a tool like JupyText to convert those different formats and check the Markdown file into version control if you'd like. And then Jupyter Lab is, all the way to the notebook interface is an alternative way in which you can interact with the traditional Jupyter notebook. And then as a community, you can improve parts of the stack piece by piece in the way that you might want it. And you make the whole ecosystem better by making it more future-proof and flexible. So I'm going to focus a bit more on sort of the community aspect of the work that I've been doing and pointing out and highlighting a tool called Jupyter Book and the MIST engine to bring modularity and reusability to scientific communication. So what is Jupyter Book? It lets you create an enriched and interactive multi-document narrative. So you have a bunch of Markdown files, you might have a bunch of Jupyter notebooks, and you want to convert that into some kind of output like a website to share with other researchers. And because of the modularity of the whole ecosystem, you can add extensions that integrate with the Jupyter Lab environment. In terms of presenting and formatting your outputs, one particular format for that is obviously websites. But academics, they often might want to publish their work in the form of PDFs or things like Word documents. Sometimes LaTeX documents, or you might want to have a website that's interactive so that students can engage with the content. You might want to put that next to some data so that they can explore a data set. And you might want to be fancy and have people execute live code on there, for example. There's also JATs. Some people are concerned with having the metadata in order to reference their literature. There's also other people's last miles might be, oh, I'd like this to be entirely editable in Jupyter, and other folks might prefer to have an editor in VS Code. So the last mile for everyone is very, very different. But what's probably in common with everyone is they want this to all happen super, super fast. So to achieve that, the next version of Jupyter Book will be based on a MIST-MD engine, which is a next generation document engine. So for those of you who are more familiar with the underbelly of these documentation systems, we have something called Sphinx, which is Python-based in terms of its runtime and how you might code its extensions. This is what Jupyter Book used to be based on prior to version 2. But we're now moving to more modern front-end frameworks and also using TypeScript as the runtime and writing extensions in JavaScript. And the reason why we're doing this is because we want Jupyter Book to be more ubiquitous, structured, extensible, And also, underlying everything, it's a community-driven project. So I'll go into each of these points, and the first one is the ubiquity. So if you have been writing Jupyter books using the underlying Sphinx engine, we want to make that transition very simple. And we have extensible and semantic syntax baked into the MIST engine. So for those of you who don't often write technical content, in terms of authoring different types of components that you might want to render in a website, in a Jupyter book, you'll often come across these things called directives. So these are like code blocks which are indicated and opened by these 3 backticks, and then you'll have some kind of directive name which can take some positional arguments, maybe some keyword options, and then you'll write in your content in this block. So what that looks like in practice is, for example, if you want a warning box, then this is how you would write that out in Markdown, and you can see the rendered output on the right-hand side. Similar thing, like often you'll want to insert figures into your documents, and this is how it's rendered here. And the last one at the bottom is a demonstration of a more fancy component called a card, which takes quite a lot of different arguments. But yeah, this is how it's presented. And then I'm moving on to how MIST sort of structures its data. So it exposes its content as structured data. So every MIST document is composed of structured and semantic data. So you might have, your rendered output on the left-hand side that looks like this, but there'll always be essentially a JSON file. I think like yesterday in the Wikimedia talk, there was a similar approach with, how do you represent textual data as a piece of structured data to pass for like machines. And MIST does a similar thing in providing an abstract syntax tree for your content. And so having this structured data means that you can take your collection of Markdown and notebooks, turn that into structured content, and then you can publish and render that into many different formats, many times, without much heavy lifting. So that structured content is rendered into your websites and journals, or your PDF, LaTeX, and Word documents. And another advantage of having this structured content is that it allows you to connect your ideas. So on the left-hand side, you can hover over citation references, and it will pull in some rich information. Similar thing on the right-hand side, you could hover over a reference to a figure, and it can use the structured content to pull in the data to preview your figure reference on the right-hand side. And it also lets you connect to external data. So I think in the demo right now, you can hover over a GitHub pull requests and it pulls in information from GitHub. You can hover over a DOI reference and it pulls in the metadata for a paper. Same with RRID. And then I think at the end of this demo, you can see a hover to Wikipedia links as well. So it pulls in information from Wikipedia. And obviously, as a tool that is part of the Project Jupyter ecosystem, it's very well integrated with other Jupyter tools. So you can render MIST very easily within JupyterLab. So you can blend computation with narrative within your interactive JupyterLab environment. I think this video is not playing, but it just shows you how you execute a Markdown cell and it renders this particular directive here. And then also you can connect your document to Thebe. So this provides interactive computation to a static web page. So if this video was playing, I don't know if you can click a play button, but you can see there's a power button at the top of the piece of text. And then once you click that, that will connect to a compute kernel and then execute some cells within this document that's below this text. And then, okay. And the final point I wanted to expand on was that MIST is driven by a community. So we have an open governance structure. There is a team compass out there if you'd like to sort of explore how we make decisions and how you can contribute. If you're interested in engaging with the community, there is a Discord as well as a GitHub organization. And you can go ahead and try it out right now. So if you head to mistmd.org, it's super easy to set up. If you want to try it out, I think there's also like a sort of like a widget on the homepage in which you can sort of try it out directly in the browser as well. With that in mind, I'm going to sort of talk about how I've used this particular tool to build communities around it in order to create and share knowledge. So often there is an unmet need for interactive computing infrastructure for knowledge creation. We have, thousands of siloed global scientific communities that seek to create and share knowledge with each other. We've got things to import and lessons learned to share with each other, but they sometimes face some challenges. And often that boils down to the lack of access to the infrastructure. It could be, the lack of expertise, lack of time, or even lack of funds. There's often, quite a big overhead with running and curating your own environments. This is often, an overwhelming, complex horizon of open source tools that it's difficult to navigate in the first instance. And often there is friction to share ideas and move workflows around due to a lack of sometimes accessible services with portable tools and standards in the open science space. So we need infrastructure services that are driven by community needs and values, that follow the same open source science principles and practices we wish to see in others. We also want these services to be globally accessible and sustainable. So this is where my workplace comes into play. So I work at 2I2C, which stands for the International Interactive Computing Collaboration. And we're trying to build a global network of community Jupyter hubs for education and research communities for interactive learning and discovery. We're a non-profit, and we're all very much, in line and aligned with open science principles and open principles. We really want to make our approach super transparent in that open source sense, and we try and keep our incentives aligned with community needs. We seek to empower communities to actually own their services. So we might run and operate things, but we operate our infrastructure as code, and it's open. Community participants can, make contributions and changes through there. And they can even manage and run their own service without us if they wish. So we're really driven by partnership. We work with communities for shared impact, not just to grow revenue. And we try and sort of strive for a self-sustaining model so that communities can ensure continuity, growth, and funder independence. So I've got a few case studies coming up. So we're really sort of focused on empowering communities to own their digital spaces and create and share knowledge with them. So one aspect is the resource management. So we're actually sort of training as well as just providing the service for community leaders to actually administrate their own hubs in the cloud and giving them the tools to monitor their costs and keeping things reliable and predictable. So one of the communities we work with quite closely is the NASA Veda community, and they themselves curate their own software environments. We don't touch that. They do that. So they curate their own software environments, and also they provide their own users with drop-downs for machine types that are paired with the environments that they have available. We focus on knowledge sharing. So we empower domain leaders to provide guidance for their respective communities and domains so that they can learn and share contextualized workflows within their own community, keeping it healthy. So one such example we have is the Cryo in the Cloud community. They use JupyterBook to share with others how they use a package called IcePix to access NASA Earth data and share those workflows in order to do their cryospheric research. And then we're focused on interactive computing, so we're helping end users as well sort of explore things like cellular imaging for themselves. We provide advice and support for how you curate those environments and how to connect to the data and resources to provide interactive demos like the one on the right there. And so there's this real sort of like connection between open source and user communities that we try and co-design and collaborate our services for. So what we do at 2i2c is integrate a bunch of open source tools together and collaborate with user communities to provide the right service and what they need for them. And that gives us a lot of feedback and rich information for us to go to the open source communities and drive changes and developments that better serve their needs. We have a global network of over 90 communities across 5 continents. And if you want to learn more about our case studies, we have a website where you can go have a look. I'll delve into a few of them now. So I mentioned the CryoCloud community earlier. They use our Jupyter hubs to run workshops and do outreach. So it's really, bypassing that awkward local installation phase and getting them right into the compute and the learning. They've been able to sort of grow their community about 4 times to 80 users in the last 2 years. And the community champion there, Tasha Snow, won the 2023 AGU Open Science Prize. So it's a combination of different services and tools working to foster this community. So they have their Jupyter Hub, they've got a Jupyter Lab for user interface, and then the Jupyter Book to share their knowledge with each other within the community. We also help with data science education. So there's the Data 8 curriculum in California. So we deploy Jupyter hubs for over 30 community colleges there. And they, it gives them the environment and the infrastructure to do their classes. We do hackathons. So earlier this year, I went to, I think it was NCAR, to sort of convert a bunch of people's existing Jupyter notebooks and upgrading them to the Mist engine, which was super fun. And this is a particular case study called Spyglass, in which a research group from the Howard Hughes Medical Institute, basically we stood up a binder hub for them, in which they could share interactive and computational version of a research paper that they had. So yeah, that basically brings me to the end of my talk. Open science improves and stays healthy via modularity standards and communities. I've dived into the Project Jupyter ecosystem and focused very much on the Jupyter Book tool that helps create and share knowledge. And I've talked about the modular services that myself and others provide at 2i2c in connecting user communities to open source. So yeah, if you want to find out more, here are a bunch of links, and looking forward to chatting to you over lunch.
Thank you, Jenny.